Okay. People are still getting in, but I think we can already begin to at least present, talk a bit about Clea, and so later we can start hearing Gualtiero's talk. We're already recording. Felipe, is everything is in order with you? We can begin. Okay. Okay, just so everybody know, this event it's going to be recorded, and later we'll make it available at our website, clea.group. We are already recording, so if you're not comfortable, just you can turn off your camera. But other than that, we're glad to see you while we speak. Okay, well then, I want to welcome and thank you everybody for joining us. This meeting, as you know, is organized by the CLEA Research Group. CLEA stands for Cognition, Language, and Activism and Affectivity. The group was founded in May of 2020 with the purpose of uniting researchers from different places around related themes and interests, despite contemplating a wide spectrum of theoretical positions and inclinations. We assume as a group that cognitive, linguistic, and affective processes cannot be fully understood outside of the agent-situated activities in his or her physical and social environment. So you can find more about us and our members at our website, which is clea.group. I believe Felipe is writing down at the chat right now. So please keep in touch if you want to know more about future events like this, as well as the group's activities and further publications. And you can also, at our website, you can also find the recordings of our previous meetings. So today, we are launching a series of events we called Foundational Issues in Cognitive Science. This is the first event. Our goal is to gather researchers interested in discussing the possibilities, the challenges, and the future directions of cognitive science in general. So in order to help us tackle with these questions today, we're really glad to have here with us Professor Gualtiero Piccinini and Professor Marco Facchin. Now let me quickly introduce both to you before we begin. Professor Gualtiero Piccinini is a curator, distinguished professor in the philosophy department and associate director of the Center for Neurodynamics at the University of Missouri. He is widely known for his work on the nature of the mind and computation, as well as on how to integrate psychology and neuroscience. Today, he's going to present us a recently published work called Situated Neural Representations, Solving the Problems of Content. And Professor Marco Facchin is a research fellow at the University of Antwerp. He works mostly on neurocognitive representations, extended mind, extended consciousness, and the mark of the mental. Today, he's here to make comments on Piccinini's presentation and, of course, present us his own view. So now this is how we're going to work. First, Professor Piccinini is going to give us a talk. He'll have 4 minutes for that. Then Marco will have up to 30 minutes to make his comments, to make his own presentation, and, of course, present his own view while doing that. And after that, Piccinini will have another 10 minutes to reply to Marco's comments. Finally, at this point, my colleague from the CLEA group, Sergio, who's already here with us, I believe, will pick up questions from the audience for a few more minutes. And after that, we're done. So now, if everything is in place, I will invite Professor Piccinini to begin his talk. So, Professor, whenever you're ready.
Hi. Thank you very much. Thanks for inviting me. It's great to see a lot of already known faces and meet new people. So as Kyle said, this is a paper that's already been published, but I will give you some highlights. And sorry, my dog was barking and she asked to go outside. So let's move. One small clarification. I am no longer at the University of Missouri St. Louis, where I was also the associate director of the Center for Neurodynamics. Now I am at University of Missouri in Columbia, and then there's no Center of Neurodynamics there. But I'm still a professor of philosophy there. Okay, can we move the slide? The next slide is just some brief acknowledgments of some other sources for this material. I have a 2020 book on neurocognitive mechanisms on which this built. And then there's a number of people that have done work in this area that is especially relevant, and there's many more that are not listed there. Next slide, please. So the main thesis is that the situatedness of the nervous system in the body and environment is intertwined with the construction and the efficacy of neural representations and the content of the neural representations, and that if we think of the interconnection or interdependence between these two, we can solve some long-standing problems in the theory of the content of neural representations, and then by extension mental representations, because I think that mental representations ultimately are neural representations. More in detail, if the system is embodied, embedded, it dynamically interacts with the environment and uses feedback to shape the representations and computations and manipulate the representations, then we can construct, or the system can construct, representations with original semantic content. The vehicles are automatically coordinated with the content. The content is causally efficacious. The content is determinate enough for the system's purposes. It represents the distal stimulus as opposed to some other intermediary cause, and it can misrepresent. These are all things that have been discussed at length in the literature for decades. And I think that we can solve these problems if we think of the situatedness of the system and the representations that are built by the system. I will only focus on the first three, but the paper, the published paper, talks about all six. Next slide, please. So the first problem is, where does original content, which is an aspect of original intentionality as opposed to derivative, come from? So just to illustrate, for example, the word burro means butter in Italian, but donkey in Spanish and Portuguese. And this is derivative semantic content. It depends on the speakers of the language and the language that they speak. So the type of public representational systems that we manipulate, like public languages, and also many representational systems that we build, including the states of most artificial computers, have this kind of content, derivative. It depends on the interpretation of the user, let's say. But when an Italian speaker understands the word burro, they form, presumably neural representations that represent butter. And a Spanish or Portuguese speaker, in a normal linguistic context, not now, but they would form neural representations that represent donkeys. And this is original semantic content. There's no need for an interpreter to interpret the meaning of the neural representations, or at least that's a fairly widespread view. So if that's the case, let's just go with that. How can neurocognitive states acquire original content? That's the problem of original content. Next slide, please. Second problem, this one is not discussed as much, is the coordination between the vehicles and the contents. So if you do automatic translation, for example, you need to coordinate the input to the output in a way that match, their meanings match. Okay, so you translate something like questo è un cane in Italian into this is a dog, questo è un gatto into this is a cat, and so forth, and you don't mismatch your translation. So the translations have to match in meaning, in content. So an automatic translator has to have the right operations. Okay, without getting into deep neural networks and how they are trained, if you are to set up a program to do that, you, the programmer, would ensure that the two match, that the translation matches the original in its content. But in a brain, there's no translator. There's no programmer. There's no programmer that can ensure this matching between the operations, the translation operation, and the content of the inputs and the outputs. So how does the brain match the operations, the computational operations, to the content of the representations? That's the second problem. Next slide, please. Okay, and then causal efficacy. In a computer, the vehicles, in an artificial computer, the vehicles cause computations, but the contents don't really do anything. Again, the contents are derivative. They're something that's an interpretation of the users, and they are set up, the vehicles themselves, the operations are set up so that they all match the content, but the content itself of the representation isn't really causing anything to happen. Okay, it's all like set up the right way by the programmers. Whereas, and many people have thought that probably something like that also happens in the brain, that the contents don't do anything. But many people also think that when it comes to mental/neural representations, the content has to do something. Otherwise, then it's not really, there's not real thinking or rationality. It seems that when we think of things, when we reason about things, the content has something to do with why we draw the conclusions that we do. So it would be worth thinking about this and seeing if there's a way for the contents to also be involved in the causal process. Okay, so that's the causal efficacy problem, content problem. That's next slide, please. And my suggestion is that, as I said at the beginning, we can solve these problems and some others if we think of representations as situated in the right sort of ways. And there's more than one way, and they're all sort of connected together. So as many of you probably know, historically, there's a bit of a opposition between computationalists/representationalists on one side and people who push the situatedness of cognition, like embodied, embedded, and activists, approaches to cognition. And, there are many people who, think, the explanation for behavior is computations over representations. Forget about, inaction and, embeddedness. I mean, yeah, we're embedded, but the important thing is what's happening inside the representations. Or on the other side, there are these radical and activists and so forth who argue that we don't need representations to explain behavior. In fact, that's a big mistake. We need to think of the system as being embodied, embedded, and active, and that will explain behavior in a better way. And obviously, I am not only arguing that these two perspectives instead are compatible, but they need each other. So the idea that I am proposing in this paper is that a good theory of representations and the computations that manipulate them actually needs the resources that come from thinking of the system as situated. And then, of course, in the other direction, a good theory of the situated agent is going to involve also representations, and the representations play a role, and the computations that manipulate the representations play a role in the embeddedness of the system, or the situatedness of the system. Okay, so if we have if we think of it in the right way, then we can find that the system builds its own original semantic content, along with the computations that go with it, because this is really the one and the same process. It's one process of building and learning the representations and the computations that manipulate them together. And because it's done together, then the content is going to be automatically coordinated with the vehicles and the operations that manipulate the vehicles. And for the same reason, then the content is causally efficacious. Next slide, please. So to get into a little more detail, one piece of background is what kind of representation are we talking about? Many of us have come to the conclusion that the right notion is that of structural representations. So it's a system of, to begin with, at least, it's a system of states that has the following functions. There's differences in the way that these are defined, and actually, I believe Marco Facchin, who's the commentator responder, has a recent paper where he goes into different notions of structural representation. This is one that I have used in this paper. So the system of states is partially isomorphic to the target. Each state carries natural information about its target, which means that it raises the probability of a certain thing occurring, when it's activated or when it's, token presented, in the system. It can be activated by signals from the target. It can be decoupled from the target, when needed, meaning it can be activated even if there is no signal from the target. For example, as when I can still represent that my dog is out in the yard, even if I'm not seeing the dog right now. The dog might be not visible at the moment, but I can still represent it there. And finally, it can guide behavior with respect to the target. Okay, next slide. Now, we are not talking about structural representations of any sort, but neural structural representations. So what is special about neural representations? One thing that is special is that neural representations simulate their target, or at least like many types of neural representations, they model and thereby simulate the target. So they are evolving to match the evolution of their target, at least to some degree, and kind of predicting the evolution of their target. So there's this dynamical aspect to neural representations. They're not just there, sitting there and waiting for signals to come in. They're active. They are always, trying to predict what's happening. And also, there is this learning element to neural representation. So neural systems build and maintain simulations of their body and environment, use these simulations to guide behavior, and also, crucially, they use information from the body and environment together with their own motor commands to update the simulation, to update both in terms of what the next state of the simulation should be, and also, we're going to get into it, learning and improving their models. So next slide. So learning, is a very important aspect of how neural systems, neurocognitive systems, build their representations and use them. And there's different kinds of learning. And here's a list of some of the main types that are kind of used in the theory of artificial neural networks. And I probably don't need to go over each one and what they mean. But there's different methods for training artificial neural networks. Some are supervised, some are unsupervised. There's self-supervised, which means that the network itself extracts some supervisory signal from the data by trying to predict how a sequence of inputs will continue. So it uses the inputs it's already received as the beginning of a sequence or a pattern, and then tries to predict how they're going to go. And then if it predicts correctly, that kind of helps to confirm the the way the model works, and if not, it needs modification. And then there's reinforcement learning, where there's some kind of signal received from outside the system that it can provide either a positive reinforcement saying like, yeah, this was a good move, a good action, successful action, or a bad move or unsuccessful action. And so that can be used to either positively reinforce a model or modify it to try to nudge it in a more accurate direction. Okay, so so some combination of these, not so much the supervised kind, but some combination of the other kinds, are presumably used by neural systems, like biological neural systems, to learn. And this process of learning shapes both the representations and the operations that are performed on them. Because as the neural network learns or gets trained, it's not like there's a separate learning of the representations and of what to do with them. Those two things happen together, at the same time. So the representation and the computation are intertwined in a way that they're not in a conventional artificial computer. Okay, so this is already a step towards original semantic content, the fact that the operations and the representations are acquired together. Can we have the next slide, please? So I am using this term active learning for the type of learning that is in place in biological systems, biological neural systems, in an organism. And what is characteristic about it is that it uses real-time feedback from the system itself, its body, and the environment as the organism is acting, in its environment. So this is happening all the time in real time. And as I said, there are these two different things that happen in a neurocognitive system or neurocomputational system. There is the computation of, or the simulation of the target. The target is everything, basically, everything that's relevant. The organism itself, it simulates its own body, and it simulates the environment and the interaction between them, but also learning, which is improving the models that the system builds, the representations. Okay, and there's, I think there's different sources of learning. I listed 4 that seem important. One is the timing and frequency of the input signals. One is the channels through which the signals arrive. Some can be like visual, auditory, somatosensory, and so forth. The correlations between different portions of the signal. So, that's where like self-supervised learning can occur if you notice that when you get certain kinds of inputs, then other inputs are likely to follow. That's an example. And dependencies between the inputs and the outputs and the internal states of the system. So there's going to be different dependencies depending, for example, on whether the signals are coming from the body or they're coming from the environment. So the system has to learn what's part of itself and what's not. Well, one thing that might help is signals from itself are always there. Signals from outside depends on where you are. So there's, different types of dependencies between inputs and outputs. Can I move my own, these things when I want, then it's part of me. If I have to, grab it and I can let it go, then it's not part of me. Okay. Next slide. So, this is kind of the deeper level of the argument, is that this kind of active learning requires embodiment. The sensor and effectors are in the body, and the feedback loop between the system and the body is needed to learn that, quote unquote, that it has a body. This is, a slightly misleading way of putting it, and how it can simulate and control it. So I think the more fundamental way to think about it is, or the more basic way to think about it is, that the system learns to simulate its own body and control it. So the simulation is used to control the body. So implicitly, because it can control its own body based on its own simulation of the body and the feedback that it receives from the body, it knows that it has a body. I'm not thinking this as like a kind of language of thought, representation, or anything like that. It's just that there is a distinction between how the simulation of one's own body works and how the simulation of the world works. So that when we go to the world, we go to embeddedness. Active learning requires embeddedness. The environment contains information to be learned. And there's a feedback loop between the system and environment that is needed to learn that there is an environment out there and how to simulate and how to intervene in it. I wrote control on the slide, but maybe intervene is a better term. So you can intervene in the world, but that's a bit different from controlling your own body. You can always like move your body, but to change things in the environment, you have to be in the right place, and you have to, make certain interventions on things that you don't control directly in the same way, and you don't have the same kind of direct feedback from. So it's a different kind of feedback that has to go through the environment. So the system can notice these differences, and that's how it can presumably distinguish between itself and the environment in its own models, in its own representations. And there is also a sense in which inaction is needed. Inaction can mean a lot of different things, and we could talk about that all day. But one important notion is that there is this, interdependence between representing the world and yourself in the world, and how the two can interact or do interact, and acting in the world. So I am, it's partially a guess. I think it's very plausible that the system uses this interdependence and the interdependence of the sensory inputs and the motor outputs to learn how to guide its own behavior in response to its own models. And then finally, reward signals seem to me a very basic type of affect. So even affect is built into the way that our nervous systems learn from the environment, insofar as there's actual reinforcement learning going on, which I think is very plausible. This is like mainstream psychology and neuroscience, and it's not like my idea. So in other words, like reinforcement learning builds a basic form of affect into the way the system learns, and the way the system learns, in fact, it acquires representations and computations. So representation and computations have an affective dimension right there. Okay, next slide. I think that this situatedness and the way that learning depends on it solves the problem of original content. The originality of the content emerges because of this active learning process from the interaction between the system, the body, and the environment. And the content itself is just a property acquired by the representation via this process of active learning. And specifically what it is a kind of causal power to track its target and guide behavior in response to the target. So there is a tracking element to content, and there is a active guidance element to it. This is, again, it's a twist on an old idea. Ramsey, I think Frank Ramsey said that beliefs are maps by which we steer. I hope I'm not misremembering who said that first, but in any case, it's an old idea, but it applies to, I think, a situated neural systems that builds its own representations. Next slide, please. So we also have a solution to the coordination problem, because these semantic contents of the internal representations are an aspect of the functional role of the representations themselves, or the vehicles of the representations. As I said already multiple times, the the content and the computations are acquired together. Well, the representations and the computations are acquired together, and the content is an aspect of the functional role of the representation. So it's also acquired as you acquire both the vehicles, if you will, and the computations that manipulate the vehicles, both like, upstream and downstream from those vehicles. So, there's a process by which the system kind of activates a certain state of its own representations, the simulations of the body and environment, and then it uses them to guide behavior. So this is always happening. There's always this like building of the current state of your internal model of self and world and guiding behavior on that basis. Not that every aspect of the model is used to guide behavior at all times. There's always like some selection of appropriate actions in a certain moment, but still there's always that interplay between updating the model and guiding behavior. So the content and the computation are already automatically coordinated. Next slide, please. And also it's also a problem with the causal efficacy of content, because again, the content itself, in my opinion, is, or at least like the most useful way to think about the original semantic content of neural representations is as something that has this tracking element. It's tracking its target, but it also guides behavior in response to the target. So it's a kind of special causal power of these states that are embedded, or let's just say they are connected to the whole representational and computational system. So of course, it's not just that the states themselves, like neural firings in one location by themselves don't have specific content, but if they are connected to the larger network and neural system that manipulates them in certain ways and can guide behavior that way, that's how, and it's situated in the body and environment, that's how it comes to have that semantic content. So it's a property that is of those states, but in virtue of the way they're connected to the rest of the system, which itself is part of the body and embedded in an environment and acting in that environment, or potentially, at least, you can sit there and not do anything, but potentially active, okay? Or even potentially active internally. Even internal action counts. I didn't specify that, but sometimes we just act in our own brain, and that still counts as a kind of action. So, I'm taking an action in a broad sense. Okay, it doesn't have to involve moving the body necessarily. Okay. So anyway, as a result of all of this, the system is sensitive to the content of its vehicles. This is, an indirect reference to a traditional claim that, computational systems are insensitive to the content of their vehicles. Is something that Jerry Fodor said, but some of us disagree with that, and this is why. And this is why I disagree with that. Okay, next slide. We're getting there. So in conclusion, or in summary, a properly situated neurocognitive system can construct neural representation with original semantic content. Excuse me. The neural vehicles are automatically coordinated with their content, and such content is causally efficacious. And there's other problems of content that traditionally have bothered philosophers who have thought about this that can also be solved by the same approach, in my opinion. Thank you.
Okay. Can you hear me? Okay. Thank you so much, Gualtiero. It's been a great talk. And I will now invite, let me just unshare the screen. I will now invite Marco to begin his talk. So Marco, now you have up to 30 minutes to make your comments and present your own view as you like. Let me just stop sharing so you can share your own screen. And then after that, feel free to begin.
Okay, so thank you everyone for being here and for having me. I need to minimize this. And okay, so let me start. Uh, Let me start by saying that I wrote the commentary by uh, reading the paper. So when I was reading the paper, it seemed to me that Gualtiero had basically two objectives that he was trying to achieve. The first one was to sort of persuade us that not only situated cognition writ large and standard computational approaches were compatible, but that they uh, should actually be run together. And the second um, objective was to show that you need to run them together because that's the only way, or at least the best way, to solve a number of standard metaphysical problems of content related to content causality, the coordination between contents and vehicles, the source of original contents, the problems of distality and determinacy, and so on and so forth. So I am a moderate, apparently, supporter of situated cognition, and I think a fairly persistent critic of representation. And so I think I'm the kind of person Piccinini is trying to talk with this specific paper. And the question I want to comment the paper on is on whether it manages to persuade people like me, say, that we should run together situated cognition and computational representational approach, and that's our best shot in solving a huge number of metaphysical problems of content. And I think that to the surprise of roughly no one, I will argue that I'm not convinced, that I think that in Piccinini's account, situatedness plays a very minimal role, and so that situated approaches and computational approaches are not um, reconciled in any relevant and substantial sense, at least if you look at the matter from the perspective of a fan of situated cognition. I will also try to argue that it's not really clear what situatedness amounts to and how it solves the metaphysical problems of content. And then, if I have the time, and that's a big if, I will also uh, argue that we have independent reasons to be skeptical of the sort of content grounding story Piccinini offers. So let's start with the first thing, with situatedness playing a very minimal role. So I think that Piccinini is right in saying that in principle, at least in principle, standard computational approaches and situated approaches to cognition are not mutually exclusive. People like Andy Clark built their careers around them not being mutually exclusive and in trying to fit them together. But still, I think that there's an important sense in which the claim that situatedness and computation are compatible together, there's an important sense in which this claim is ambiguous. Minimally because you can read situatedness and the appeal to situatedness in at least two ways. There's a sort of weak reading, according to Nguyen and others, according to which situated factors concerning the agent's embodiment, its environmental embedding, its affective state, and so on and so forth. There's a weak reading according to which those factors are causal contributors to cognition or enablers of certain cognitive processing. And then there is a stronger reading, or a strong reading, where those factors are constitutive components of cognitive processing, not just things that impinge upon cognitive processing, but part of cognitive processing themselves. So the first question is, what sort of claim is Piccinini making? Is claim that situatedness are situated factors play a causal role in cognition, in our inner computation, or that they partially constitute our computation and our cognitive processing. And to me, at least, is not entirely clear from the text what of the two claims he wants to make. I think you can cherry pick in favor of either by reading different passages in the text. But I think that a charitable reading of Piccinini's overall position sort of invites the weakest reading, the merely causal reading, if you want. And the reason is that for Piccinini, cognition is computational, and computation is medium independent. What matters to computational processes are just the organization and the degrees of freedom that computational states can occupy and the way in which they can influence each other, and not the physical medium in which they are implemented. So if a physical medium supports the right degrees of freedom and the right of sort of causal organization, then it can implement a computation, but only because it supports that degrees of freedom and that organization. The physical material aspects of the medium are irrelevant. The problem is clearly that in the case of strong forms of situatedness and embeddedness, the material aspects of the medium itself are relevant. And one, I think, standard example is morphological computation. My go-to case is morphological computation with plastic grippers. So what robotics has basically discovered is that to control an entirely rigid system is very hard, especially if you want that system to grasp things in a firm way and without risking breaking them. So what they did is that is to substitute certain hard parts of the grippers with plastic parts, with plastic components. And those plastic components are rough in texture, which helps with gripping stuff, of course. And they're also somewhat flexible. So they passively conform to the shape of the object to be gripped, again, improving the grip. And by being somewhat flexible, they minimize the risk of breaking the object to be gripped. And here, clearly, the physical medium itself matters. If you were to substitute this sort of plastic here with metal rods, then the robot wouldn't be able to grasp a pepper and to hold it sort of upside down, and it most likely the pepper would either fall or be crushed under the pressure of the metal rods. So it seems that, to me at least, that in order to account for this sort of cases, Piccinini must somehow reduce the contribution of the plastic gripper itself to the causal impact it has on the inner computational process of the robot. Say, the fact that the inner computational process don't have to compute on so many variables for the compliance between the gripper itself and the object, or they don't need to control the pressure of and the force of the grip so tightly. And there's nothing in principle, say, wrong about that. The only complaint I have is that such a weak reading is not situated in any substantial and interesting sense of the term, because an inverted control system could be situated in the exact same way, provided that the VAT take care of the motor variables the control system is not longer computing on. Now, the point is not that Piccinini's position is open to external world skepticism. Pretty much each and every philosophical position is. The problem is that it uses a sense of situatedness that's compatible with brains in a vat. I just think that that sense of situatedness is not situated enough to appease defenders of situated cognition. is, at least if you are already into situated cognition and look at this paper from this perspective, what you get is not a genuine conciliation between computationalism and situated cognition, but what you get is a slightly lighter, say, less computation-heavy version of computationalism. So that's my, say, first malcontent in respect to Piccinini's proposal. Now, the second, say, objection I have is that it's not really clear what situatedness amounts to in Piccinini's story and how it actually contributes to solving the problems of content. So again, appeals to situatedness are very ambiguous and can be read in a variety of ways. And when it comes to situatedness and neurorepresentations or representation more generally, there is a very weak reading concerning, say, the fact that our representation must be bodily or motorically formatted, or that the way in which we represent things is influenced by the body we have. So the fact that we represent things being or as having certain colors is clearly influenced by the fact that our eye affords us only a free chromatic vision. Those claims are fine, but it seems to me that those claims to be running and to be taken seriously need to presuppose that, metaphysically speaking, all is good with contents and with representations. So I think that the sort of claim Piccinini is making is a more metaphysically heavy claim about the role of situatedness for representation. And the claim I think he's making is that situatedness is part of what metaphysically grounds the content of representation. That representations have content partially in virtue of the fact that we are situated beings with a body embedded in an environment, with a specific affective life that interact with their environments in sensory motor ways, and so on and so forth. Now, if I were to believe that representation were real, I would, I think, agree with this claim. But I want to start to notice that it's not an entirely new claim. Teleosemantic theories of mental contents are, in a sense, situated and allow situatedness to be part of what metaphysically grounds representation. They allow evolutionary history of an organism to be part of which grounds the organism's mental contents. Now, I think that Piccinini wants to, in a way, go a step further when it comes to the role of situatedness in grounding the content of our representation. I think that he intends his proposal to be more situated than any standard variant of teleosemantics or informational teleosemantics. However, by reading the paper, it is not very clear to me what are those new situated elements and how they contribute to the solution of the metaphysical problems of content. So just to give some concrete example, take active learning. Now, there are passages, for example, a passage at page 9 that I haven't reported here, but you can easily spot it, in which Gualtiero emphasizes that active learning is one of the sources of content, of original content, together with an organism evolutionary history. Now, taken face value, the content is, on the one hand, not even by itself very new. The role of learning in making the content of our mental representation emerge is part of the teleosemantics. You can arguably find in language, thought, and other biological categories, and clearly you find it in Dresky's explaining behavior and Shea's representation in cognitive science. So it's not immediately clear how appealing to active learning makes this sort of account more situated that many, say, standard telesemantic stories or informational telesemantic stories. And it's also not very clear to me how it manages to solve these standard metaphysical problems of contents, because learning is an historic factor, and as every historic factor, it leaves open your account to swamp person scenarios. So for those who don't know, if this swamp person thought experiment was originally, I think, proposed in the late 70s by Davidson. And what you have to imagine is that there's a thunder that hits you while you are walking into a swamp, and the thunder kills you on the spot, but also generates some sort of chemical reaction with the swamp itself, and a perfect molecule by molecule duplicate of yours emerges out of the swamp. And of course, by being a perfect duplicate, the duplicate will do everything you would do. It will go to your house, open the door, say hello to your family in the exact same way you would have done it. But in the case of TAN, the important part is that the duplicate does not share your learning history. And thus, if learning is part of what grounds the emergence of original contents, your duplicate does not have any original content. He doesn't, strictly speaking, have inner neural representations at all. It just has neural states that make his body move around. Body is your causal duplicate. So it seems that in this sort of account, content is not causally powerful. It doesn't have any sort of causal bias. And of course, this scenario is not a realistic scenario, and no one thinks that really a thunder could decompose you and recompose you while you're walking in a swamp. But it shows a metaphysical problem, the problem that if content is grounded in historic factor, it doesn't seem to have its hand on the steering wheel of your behavior, causally speaking. I also think that active content and doesn't really help in and by itself in making vehicles and contents coordinate, and that situatedness doesn't really help, or any particularly strong appeal to situatedness doesn't really help in making vehicles and contents situated. Basically, any form of learning seems to coordinate between vehicles and content. And if you read, for example, the very first chapters of this book, now it's a very old book by Rogers and McClelland, about what they call semantic cognition, basically is a book about how neural network can be used as very rough neurocomputational models, I'd say. What you see is that even the learning in a totally disembodied, disembedded, effectively inert neural network, in a form of learning that's clearly supervised, it's standard backpropagation learning. Even this sort of learning that is as disembodied and unsituated as it gets, even this sort of form of learning manages to coordinate vehicles and content, manages to separate the internal spatial activation of the network in various sectors that are thematically organized in a way that is, say, content sensitive. So there seems to be just no special role for situatedness in coordinating between vehicles and content. Any form of learning, even very disembodied and artificial ones, seems to do that. Another example, and then I swear I move up. Piccinini proposes a sketch of, in that specific paper, a sketch of function as contributions to one organism goals, which from the point of view of many defenders of situated cognition, it's actually an improvement on standard telesemantic stories. It's clearly more it's really closer to certain views of organisms based on the need for organism to maintain themselves and constantly produce themselves. And those views of organisms, especially the one connected to biological or autopoietic activism, have been voiced numerous times a form of discontent towards selected effects, historical accounts of function. So that's actually is one point in which I want to praise Piccinini's work for really getting the computational approach and the situated approach closer. But even granting that, it's hard to see how this account of function helps function to be more determined in a way that makes content determined in the required way. After all, if you take the standard example of the frog's tongue snapping reflex, it's not clear what the reflex is supposed to accomplish. It's supposed to catch prey, catch flies, catch insects, gather nutrients, feed the frog, allow the frog to stay alive, catch non-poisonous things in the environment that move, or something else entirely. Those are all contribution to the organism goals that the reflex performs. So its function seems to be indeterminate, and so the content of the states triggering the reflex seems to be indeterminate too. And so to sort of sum it up, the account Piccinini offers doesn't seem to me to be especially situated, at least no more than many telesemantic accounts are. And when situatedness is explicitly brought about, doesn't seem to manage to do anything decisive in solving the standard metaphysical problems of content. Indeed, if you look at active learning, it seems actually to be inviting old metaphysical problems of content. Now, I think I have enough time to do the third point if I am a bit faster. So I want to give you a quick independent reason to be somewhat skeptical of Gualtiero's content grounding story. So yeah, I want to give you a principal reason that's in a way independent from situated cognition to be skeptical. And well, if I read Gualtiero correctly, he seems to be presenting his own view as an improved informational telesemantic story. So an account of original content where content is constituted by basically two ingredients: informational relations between internal states of an organism and external things, and proper functions of the organism, which may be due to active learning. However, reading the paper, you can't but notice that the sort of story about content Piccinini tells has many more ingredients than informational relations and proper functions. You have, of course, structural similarities. It's clear that Piccinini thinks of situated neural representations as structural representation. Functional roles play a role, pardon the pun, in grounding content. There's simulation as a part of what grounds content and gives its causal bite. There's learning, which is mentioned, and I'm not sure that the list I've just given is complete. So there really are a lot of factors involved in the content grounding story. Now, again, this is not in and by itself new. There are already existing accounts of content that appeal to a plurality of factors, such as the account of content that Nicolas Shia gives, in which there are various distinct and mutually exclusive content grounding relations. But Gualtiero doesn't seem to hold this sort of view in which there are a number of different and mutually exclusive content grounding relations. It seems that all those ingredients are supposed to be present, more or less present, present to varying degrees, say, in all cases, and it seems that they're all part of a wider and more complex content grounding relation. It seems that they are partial aspects of a more complete relation between internal states and their targets. I think that this is frankly problematic because in many cases those factors clash when it comes to determine the content of mental states. So a very standard, I'd say, example is the Kimu's North story offered by Piotrowski in a very old paper. And I just realized that maybe not everyone is familiar with it, so I'll very quickly recount the case and then probably shut up. So Kimus are very simple organisms that live in an environment, and they are preyed upon by Snorfs that are other organisms. And Kimus are, for whatever evolutionary reasons, unable to perceive Snorfs in any ways. One day, one fortunate Kimu is born with a mutation that makes it particularly sensitive to the color red. And when this fortunate Kimu sees red, it rises up sort of this way on the top of a hill and looks at the only source of the color red that's present in its environment, which is the sun, either setting or rising. By being on that hill and purely by chance, the Kimu manages to escape the predators. Snorf don't go on that hill for whatever evolutionary reason. And so the Kimu with the mutation is very successful in reproducing. And in a span of a few generations, all Kimus are very sensitive to the color red, and they all collectively go on the hill to see the sun rising or setting. And they clearly have an internal state that's responsible for this behavior. And if you are a representationalist, you think that's a representation. And the question is, well, what is this state supposed to represent? And Piotrowski basically noticed, well, if you look at the upstream functional role, if you look at the sort of information this state carries, the answer is that the state represents red or redness. If you look at downstream, what the state does, its behavioral function has nothing to do with redness and everything to do with the avoidance of Snorfs or the rising of hills. So here you have a case in which various aspects of the functional role of an internal case were conflicting when it comes to determine the content of that state. And I had a more sophisticated case in mind, but I don't have time to talk about it. And I think that the problem is compounded the more ingredients you add. If you also had structural similarity, nothing grants you that that state will be structurally similar to the sun setting, falling, or the absence of Snorfs or hills or whatever. And basically, the more ingredients you pour into your content granting recipe, the more those ingredients have the chance to conflict with one another when it comes to determine the content of representations. Those are, which you see on screen, are the reference I used, aside from the 3 reference to myself that I haven't actually used because I've spoken too slowly, sorry. And I thank you for your attention, and yeah, I hope I have not bored you to death. Thank you.
Okay, thank you so much, Marco. It was a very interesting talk. And now I will invite Piccinini to make his reply. So Piccinini, you have now about 10 minutes to make a reply, make your comments on Marco's comments. And after that, we'll open then the discussion to the audience. So whenever you're ready, feel free to begin.
Thank you, Marco, for those very rich comments. Let's see how many I can respond to. I'd say probably the most important is the first. In my proposing a weak or causal notion of situatedness as being part of my story, or a strong or constitutive role for situatedness. And you said that, charitably, you think it's better to interpret me as offering a weak reading because I think computation is medium independent. I would say, at the risk of infuriating other computationalists and representationalists who abhor the idea that situatedness is constitutive of cognition, I would say that situatedness plays both a causal and a constitutive role. And for two reasons. One is that I argue that situatedness is part of the learning process, and the learning process, is what builds representations and computations in a neural system. So that seems to me a constitutive element, even though it is, as you point out, a diachronic process, the learning process. It's etiological. But also because, and maybe this is the central point, because as I try to explain, but maybe I didn't explain it well enough, the situatedness of the representations is also part of what gives them the content that they have. So the situatedness helps to constitute the content. So that is a constitutive role. But it is done in virtue of the causal network that is that involves the system within the body and the environment. So it's both causal and constitutive. Okay, so that's point number one. Then there is, actually, there was some preliminary comment I wanted to make, which is that it seems, based on these comments, it suggests that somebody should write a new paper addressing all these more traditional philosophical concerns that I didn't deal with in the paper. So if anybody wants to write a paper on that, feel free to get in touch. Or maybe we can write it together, or maybe you can write it and I can be a consultant. So going to the second point is swamp person. I would say, yeah, swamp person, of course, didn't learn anything, but they do have that situatedness that gives their states semantic content. So in my opinion, a swamp person does have genuine representations with genuine content, even though they didn't learn those representations. It's a bit of an aberration and a bit of an anomaly because they didn't go through the normal process of acquiring the representations, but that process is not required to have representations. It's just that it is the way that we acquire the representations, and there's not really any other easy way around that for us. But if the swamp person kind of comes out of the swamp already formed with the right kind of causal structure, they would still have both the tracking aspect of their internal states and the action guidance aspect. So that's what is needed for content. Next bit is Oh yeah, because, and this is where my approach to telesemantics is relatively different from most of the other traditional versions of telesemantics. So, historically, as Marco points out, telesemantics invokes evolution as what gives the states their content, or maybe learning as what gives the states their content. But what I actually claim is the source of the content is neither evolution nor learning. It's the causal powers of these states in their current context, the current, present context in which they are. And that includes the whole situatedness. Third point is that any learning, Marco points out, generates a coordination between vehicles and content. So there is no special role played by situatedness. And I think there's a miscommunication here, because I said, even in the talk, but I'm pretty sure I say it in the paper, that effect of learning in a neural network where there's a coordination between the vehicles and their content and the processes. Yes, it is generated by a learning process, whether or not it's situated. And that is a step. I say it's a step towards original content, but it's not yet original content. To get original content, you need the situatedness. So situatedness, does play a very important role. And it's needed for full-blown original content. And then how does it help? How does my approach help with to make content determinate? Does the frog represent flies or food or nutrients or black dots? And this is something where, again, I think that there's room for writing a whole new paper, because I didn't really get into it in detail in this paper, but it does what. So one thing I would like to say is that I think this literature suffers a little bit from assimilating these kinds of contents of these kinds of representations a little too closely to propositional representations, with propositional contents that have to be like determinate in the standard sense, in which the cat is either on the mat or not on the mat. And so either you represent food or black dots or flies. And we're using these concepts, linguistic concepts, to try to attribute content to basically the firings of neurons in the frog's brain. And I don't think that's the best way to think about the contents of these types of states. These are, I would say, generally speaking, simulations of aspects of the environment that guide behavior. And there's going to be aspects of the simulation that are more tied to tracking features of the environment. And it's an empirical question exactly what they track. And that's their tracking aspect. But then there's other aspects of the simulation, or more rather than the motor representations, that are more directly involved in guiding behavior. And in a complex system, there's all these different layers. There's all these different parts of the, say, excuse me, the brain, and some representations are more sensory, and some are more motor, and some are more in between, and some are mixtures. So I think we should leave it to the neurophysiologists, or more broadly cognitive neuroscientists, to tell us as best they can what the content of these states are. And I think they've made a lot of progress on that. So this is an actual empirical project. It's not for philosophers to decide. And then let's see. There's the question, the issue of this kind of informational telesemantics that I proposed isn't just based on information and function, but also involves structural similarities, simulation, learning. There's too many things there, or something like that. And when I say function, I mean functions within a mechanistic functionalism. So this is in my 2020 book where I talk about functionalism, and I say that functionalism needs to be merged with a mechanistic approach to cognition, or explanation in the spatial sciences in general. But functions are always tied to structures. Like, functions don't just float free of structures. You can't just give a purely functional account of things. There's not really such a thing. Even computational explanation involves mechanisms that perform the computations, and the architecture of the mechanism matters. So all of these elements, the learning, the structural similarities, the simulating, they're all and even information carrying, they're all aspects of the functioning of it to a certain kind of mechanism, which includes, the neurocomputational mechanism, but it also then includes its interaction with the body and the environment. So it's not really that there are all these different things that are not clear how they fit together. They're all aspects of the functioning of this mechanistic system. And then I kind of already hinted at what I would say about the Kemus-Narf case. That's a very simplistic example. In any kind of realistic scenario, there's going to be some representations that have more of a tracking role, some representations that have more of a direct motor control role, and then various things that are somewhere in between, and that help coordinate the two. So it's possible that a system learns to avoid predators by just responding to redness. That doesn't mean that it's not tracking redness. It's tracking redness. If these states track redness, then they represent redness, but they could still guide behavior in a certain way, and then the behavior itself, is what it is. So there's behavior that's involved in response to internal states. Okay. Anyway, there's a lot more to say, and this is there's a lot of interesting things to think about here, and I think that hopefully somebody else will also contribute to this conversation.
Okay, thank you so much, Gualtiero. Thank you so much, Marco. I want to thank both of you for a great conversation. I've enjoyed and learned a lot. And I will ask now Sergio, my friend and a member of the CLAE, to help me managing requests and questions from the audience. And for those in the audience that require an attendance certificate, I'll share the link to a form where you can identify yourself, and then we'll get back to you. So thank you. Sergio, whenever you're ready, feel free to begin.
Can you hear me well?
Sure. Yeah, that's right.
Okay, so thank you, Carlos. Thank you, Gualtiero and Marco for the talks. And now we will open for Q&A. Okay, and the first person that asked to ask a question was Francis Egan. Would you like to talk? Yeah.
I think Louise was first.
Okay. Louise, would you like to ask the first question?
Then I'll start. Thanks, Franny.
Thank you.
My question is concerns your model. Your model for the solutions to problems 1 through 3 appears to rest on an extrapolation from self-supervised learning and self-attention mechanisms and generative pre-trained transformers to robotic versions of the same. But what is the robotic counterpart, for example, to sentence completion in the classic sentence completion in self-supervised learning? In training large language models, arguably content and computation are acquired simultaneously. but what shows this to be the case in a robotic transformer model?
Okay, I have to confess that I'm not totally sure I understand the question.
Oh,
I agree that in large language models, there is a content computation matching.
it seemed to me that you needed, when you, of course, to react to the environment, you have to have input and output systems, as you emphasize. And it looks, my question is, what allows us to extrapolate from essentially generative pre-trained transformers with a robotic input function in a way that makes makes it the case that content and computation are acquired simultaneously. We know that is to be the case in training of large language models, but it looks like for your solution to work, you also need to include the robotic component. Maybe, I guess.
Yeah, I don't know if I still am not sure that I understand the question, but what I can say is I was thinking primarily about neurobiological systems and how they might work. But yes, of course, I also use what I understand to be the way that artificial neural networks learn and function and can control robotic systems. So one thing that I looked at briefly that I mentioned in the actual published paper is some of the most sophisticated control systems that existed at the time that I wrote the paper, which were these single hands, robotic hands that can solve Rubik's Cube at least like, I don't know, 60% of the time. And, I can't solve the Rubik's Cube myself, let alone with one hand. So I think that's very impressive that they can do that. And it turns out that they can't, the people who build these robotic hands, they use neural networks, but they were not able to train the neural network by using the robotic hand itself. Instead, they had to train the neural network in an artificial environment. And then once it learned the task, then they hooked it up to the robotic hand. And then the robotic hands, like with the robotic hand attached, it does work like quite well. So, then I asked myself, like, what else could be involved in in how a brain learns, because the brain has to learn in the real world. Like it doesn't have the luxury of being trained in an artificial environment. So that's part of what drove this whole reflection about the situatedness and how special our learning process is. I don't think it's fully understood how real brains learn.
Okay, thank you.
Thank you.
Okay, thank you. Now we have a question. Francis Egan, please.
Okay, thank you, Gualtiero and Marco, for really interesting talks. Can you hear me okay?
Yeah, thanks for being here.
Sure.
Great to see you.
Yeah, good to see you. So I'd like to focus on the causal efficacy of content issue. That's one of the problems that appeal to situationness is supposed to help with, but I'm not really seeing how it does anything to help with that issue. So I take it that the idea is that it's in virtue of the fact that a representation is part of a big causal network. Yeah. And that causal network can include all the aspects of the situation that 4E proponents talk about. So pack all that in to the causal, to this causal network that's responsible for cognition. But I'm still not seeing how content plays any causal role in that. So the way I see it, we can tend to think of, so as Dretske put it, how does content get its hands on the wheel? And I'm not seeing that it's getting its hands on the wheel in this picture, even packing in all this other stuff. So the way I see it, it looks like content can be causally efficacious because one of its special jobs is to make salient particular aspects of this really complex causal process salient or relevant for the particular theoretical goals of the scientist. So for example, and I've talked about this in lots of my work, just take teleosemanticists. Some of them focus on, some of them attribute the content to the frog state bug, others food, that's Nick Shea's preferred content. Small dark moving thing is roughly Karen Neander's. So they're all, I mean, they're all attributing different content to these things. So what the content attribution does in each of their models is focus on a particular aspect of this complex causal process. But that doesn't make the content itself causally efficacious. It's doing a job, a pragmatic job, of singling out a specific aspect of a really complex causal process that's relevant for a particular theoretical project. But it's not getting its hands on the wheel in the causal process itself. At least that's the way I see it.
Yeah, thank you. Well, here's the way I see it. You know, I'm thinking there are a bunch of neurons firing somewhere in a neural system, and what the content of those firings is the power that they have to, on the one hand, track some target in the environment, some aspect of the environment. And what that is something that should be at least somewhat empirically discoverable, something that can be investigated. And, you would find some approximation to that in neuroscience papers. Also, so there's this kind of backward looking or informational aspect to it, to this causal power, or causal power broadly construed, like, this is like a responsive power. It's like being able to track this aspect of the environment, possibly because there's a signal coming from it, but not necessarily. It could be that it's tracking it beyond the presence of existing signals coming from the target, and at the same time affect the rest of the system in a way that can be used by that rest of the system to respond potentially to that target in an appropriate way. So it's a kind of causal power, a complex kind of causal power that, for it to be there, requires the presence of the whole rest of the system, and how it responds to those internal states, and also how it builds it, how it builds the states in part in response to signals coming from the environment through a learning process, but also then being able to sustain those signals even beyond the signals coming from the target. So it's a causal power. It can be manifested, when the model is running, the internal simulation is running, and then it evolves, and it can guide behavior through interaction with other systems in the nervous system. So that's how it gets the hands on the wheels, because it's a causal power. That's how I think about it.
But it's not, as you put it, the content that tracks the relevant aspect of the situation. It's the vehicle. The vehicle gets instantiated in certain circumstances, and when and only when things go well, that distal property is instantiated. And in virtue of that vehicle tracking that distal property, the vehicle gets assigned the appropriate content, plus pragmatic considerations, which I've argued play an important role. So sure, because this vehicle can track this distal property, that underpins, that justifies the attribution of content, but it doesn't make the content itself causally efficacious. I'm not seeing how just bringing in more kind of vehicle-like stuff, more physically instantiated stuff from the environment really gets content into the causal picture.
Yeah, I think I understand why you think that way, and it, you know, it makes sense. You know, I of course have a lot of admiration and respect for your whole framework and all your work. It's just that, at least the way I think about it, the content is a causal power of the vehicle. So it's an aspect of the causal powers of the vehicles within the system. So it's not as separate from the vehicle as it seems when you look at least at traditional philosophical literature. I mean, I agree that if you look at traditional philosophical literature, especially say there's versions of telesemantics which are typically attribute content on the basis of historical factors, you know, then yeah, you know, you can think of it, you know, you can attribute it one way or another, and then it's not clear how content could even play a causal role. But in the story that I'm trying to tell, the content is not determined by, you know, the history of the system. It's there in the way the system functions right now.
Okay, thank you.
Thank you.
Okay, thank you. Now we have a question. Carl Sachs, I hope I am saying it correctly. You have a question, please?
Yes. Can you hear me okay?
Yes.
Okay, good. So, yeah, so thank you for this. Right, it's nice to see some faces, put some faces to some names. So I guess, Gualtiero, I'd like to hear, maybe hear a bit more of a response on your part to this really interesting objection that Marco raised, right? Because one of Marco's interesting points was, well, look, representations are going to be situated and enacted and embodied, blah, 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 then how could they be medium independent, right? And that's going to be an interesting point. I think it's important because, right, medium independence is important for your account of computation, right? So it sounds like what you might need to end up saying is something that teases apart computations and representations, teases those notions apart a bit more than maybe you had wanted to in the past, because now it looks like you could say that representations are medium dependent in a way that computations are not. I think that's part of what Marco is trying to get at. I may want to hear more about what you want to say about this. So thank you.
Thank you. Hi, Carl. Nice to meet you. I would be very reluctant to say that representations are medium dependent, but computations are not, especially because I've been arguing that computations and representations are built together. And it's not clear to me how that would even work if the representations are supposed to be medium dependent, but the computations are supposed to be medium independent. And yeah, this whole medium independence business is very tricky. What comes to mind right now, it's something that, you know, it's certainly worth thinking about more and saying more about. But what comes to mind is that I have tentatively pointed out in various places in recent years that even though computation is medium independent, in my opinion, it also has many medium dependent aspects. And the same thing applies to representation, of course. Meaning medium independent roughly means you can run the same computation on physically different media. as long as they have like, you know, relevant degrees of freedom and so forth. But they're not going to have all the same properties when you do it in a different media. Some media allow you to run the computation faster. Some media allow you to use more or less energy when you do the computation. And then, you know, of course, in a real biological system, there's going to be the interfacing of the neurocomputational system with the rest of the system, you know, the rest of the organism. And there may well be a lot of other medium-dependent aspects of the process that affect it in interesting ways. Certainly, when it comes to consciousness, you know, I'm very open to the possibility that consciousness is medium-dependent in complicated or interesting ways. So when I say computation, I mean, we're not talking about consciousness here. And of course, like the mind, like our mind, you know, also has this conscious aspect that I think is very fascinating and difficult to grasp. So medium dependence may well play a role in that, and in how like our experience also gives rise to a notion of content. You know, I'm talking about content in a kind of traditional theory of cognition way where we don't worry too much about consciousness, but there's a whole other question of, well, how does this content of representations, neural representations relate to consciousness? I think that's a very big, fascinating question. And their medium dependence is likely, I want to say, I think to play a role. So anyway, I mean, I'm kind of going in all kinds of directions here, but I would try to stick to the basic notion of computational representation that might be enough for many purposes within our effort to understand biological neural systems is medium independent in a special technical sense, but still there's a lot of medium dependent aspects of all kinds of things surrounding it.
Yeah, I guess that sort of helps, right? Because there's going to be this problem, right? I mean, to go back to, I think what I liked about Marco's point is that if you think about situated cognition, you think about different animals with different kinds of bodies. They occupy different kinds of niches. They're sensitive to different kinds of affordances, right? So there's going to be a lot of specificity that is going to really constrain the particular kinds of representations that those animals can form of their environments and of their own, right? So that there's going to be a lot of medium. So the question is like so it still feels like Marco has a point here, that there's a kind of medium dependence. Like the more you make representations situated, the more they're going to have to seem to be really medium dependent. Like that's the point Marco, I think, was making.
Well, yeah.
And that's going to be a problem with your account of trying to keep computation and representation wedded together.
Okay, but so I guess I'm trying to understand exactly what you mean. Certainly, different organisms, different bodies, and the different bodies are built in different ways, and they have different, you know, organs, sensory systems, motor systems, you know, like limbs, et cetera, et cetera. So all of that is different, and all of that is, let's call it medium dependent, if we will. But then the question is, but what about the representational computational system that is inside of there and that tries to coordinate all of that?
Right, but that brings you then onto Marco's other major point, right? If you want to say that features of the organism and its niche are constitutive and not merely causally coupled, right? Then that's also going to bring. It looks like that might be a worry about some sort of creeping medium dependence into your account representations here.
Oh, I think I see something new in what you're saying now. Maybe what you're saying is even if I maintain that this internal system of computations and vehicles is medium independent in this kind of technical sense, it could build a artificial neural network that does the same thing. For it to have the right kind of original content that in my story requires the whole embodiment, embeddedness, and action and all that, now we are bringing in the rest of the situatedness of the whole thing. Isn't that a kind of medium dependence? And if that's what you're saying, yeah, that's a good point. That's a good point, and I think it's compatible with everything else. So I don't have to give anything up. I just like the point.
Okay, thank you.
Thank you.
Okay, thank you, Carl. Now we have a question from Daniel Miller. Gualtiero, I will just read it because it is on the chat, okay, in the chat. The question is, how much agency would the subject have in your model? And more particularly, does the model have any implications for creative cognition?
How much agency does can you read it again? I'm sorry.
Yeah, sure. You can read it on the in the chat, but
I tried to find it, but I couldn't find it.
Oh, okay. How much agency would the subject have in your model? And more particularly, does the model have any implications for creative cognition? It's two questions.
Yeah, interesting question. I don't know how to quantify agency. The idea is that it would have whatever the agency is granted by the abilities of the system itself, and it can kind of all kinds of varieties. There's going to be some more complex, sophisticated agents, and some simpler agents. As far as creativity, I don't think I've said anything that helps with creativity, but I think creativity is a very fascinating topic on which it would be good to see some good work. So I hope he writes about that.
Okay, thank you. Now we have a question. Will Sharp, please.
Hey, thanks for a really fun discussion. And thanks, Sergio, and everybody who's gotten this thing together. It's been really cool. I hope I'm not belaboring or beating a dead horse, but the causal issue that you and Professor Egan were talking about, maybe even given the response that you gave, it feels like it's really easy to get causal efficacy. Just identify content with it from the get-go. But then you go, oh, it's too bad because all these psychosemanticists over the decades have really tried really hard to say clever things to accommodate causal efficacy. But anyway, the question is going to be, given that a really popular response, say Jackson and Pargeter, Dretske, Shea, is to say, okay, it's not causally efficacious in the way we thought. It's it programs events, or it's a structuring cause, which is no cause at all, or maybe it is. Why is it better to say what you've said, that it is causal? Let's just identify content with this causal power, and it's grounded in the usual grounds. But what's the advantage to saying that? What's the independent motivation to saying that? What's the advantage to saying that instead of say it's a structuring cause or it programs?
Yeah, thank you. Thanks, Will. Good. This is very good, very good. And here's what comes to mind. I think that the whole debate on the causal efficacy of content was, in a way, led a little astray by this divorce between cognition and consciousness that is at the foundation of traditional cognitive science, and of course then the debate about nature of mental representations and computations, all of which is sort of abstracting away from consciousness. And, and so people like Jerry Fodor, who are like definitely in this camp of we're just going to focus on cognition, forget about consciousness, it's like too hard or mysterious or something, then they give these arguments that, well, but yeah, if we want to explain behavior on the basis of representations, content has to play some kind of role. Otherwise, what's the point of representations? And then, but yeah, if it's going to be a computational system, content probably can't really play a direct causal role because, just think about computers, content doesn't really play a causal role there. So part of what I tried to do is argue that neurocomputational systems, at least in organisms, are very different in the kind of computation and representation involved from artifacts like digital computers. And so, these two things are built together in this whole situated situation. But ultimately, like here, I'm going to make a confession. I keep in mind that we have conscious thoughts and we have conscious experiences. And it's really difficult for me to avoid the feeling that if I'm, I don't know, grabbing a strawberry and biting into it because I say like, oh, I'm looking forward to like the flavor of this strawberry, it's got something to do with the fact that I'm representing the strawberry, not just like unconsciously in my brain, but like I can see the strawberry right there. It makes me want to eat it. So how could conscious content not play a causal role? Like it has to. That's the feeling from the inside, okay? The phenomenology of it, if you will. So eventually I would like to find a way to reconcile the cognitive, computational, informational, representational story that abstracts away from all this other stuff and in principle works even without consciousness with the conscious experience that I'm eating the strawberry because I saw it and it made me want to eat it. So yeah, there is an advantage if you can get some kind of story that makes content causally efficacious. It might help you eventually meet the experience that, yeah, that's how it really feels. Like that's why I'm eating the strawberry, because I saw it and it looked yummy.
Yeah. Before I go, do you think the phenomenology really decides between the program versus causal efficacy? Say Jackson-Pargeter versus what you just said?
I don't know if it decides, but it would be an advantage if we have a account that meets our phenomenology. It seems to me.
Thank you.
Thank you.
Thank you, Will. So I think that now we have the final question. It's from Jacopo. Gualtiero, maybe you would like to read in the chat because it's a big question. It starts with if content is an aspect.
Oh yeah, if content is an aspect of the causal power of the vehicles, which kind of theoretical abstraction should we adopt in order to get those building blocks that give us the possibility to distinguish the quality of each and every representation? What makes the content of the representation that is about the redness of an apple different from the content of representation that is about the nutritional value, and what differences they make to the economy of reason that is beyond the behavior / decision. And should I read the other part later? It says, Jacopo, I may think of structural analysis based on neurocognitive data as well as ongoing psychological or phenomenological analysis that try to build this vehicle plus content taxonomy. Of course, the level of abstraction are really different. I'm going to read it again to myself. Okay, so I'm going to do my best to see if I understand this question. There seem to be at least two aspects. One is the quality. He says the quality of the representation, the redness of an apple versus the nutritional value. That makes me think that he might be thinking of phenomenal states and their qualitative character. And I just gave an answer to Will in which I confessed that I do also think about the connection between cognition in the traditional sense and consciousness. So, but this story that I give in this paper is not about that, or at least not explicitly. So the quality is not really, at least the phenomenal quality is not part of this story. But there's also this question of theoretical abstraction, and depending on what he means by that, one thing that comes to mind, and it might be completely irrelevant to what he's thinking, but is that in a lot of the philosophical literature on representation, there seems to be a kind of implicit assumption that representations form one level of abstraction / level of explanation. There's this representational level of explanation, maybe of abstraction. And I don't think there's just one level of representation. I don't think that's the best way to think about it. I think there are many. I think there are very complex representational states, and these representational states are made out of simpler representational components, and this matches a compositional structure in a nervous system. So it's not just that representations have parts. Yes, they have parts, and the parts of the representations are states of parts of the system that carries the larger representations, and there may be many scales at which this can be studied. So there may be multiple levels of representation, and therefore multiple levels of abstraction of the system that you have to look at to study, complex representations and their components, and how the components form or organize themselves into larger representational systems. So this is part of a mechanistic framework where the system is a mechanism. The mechanism has parts. The parts have parts. The parts have parts, and each part has its own powers and properties, and the powers and properties of the parts can make up the powers and properties of the whole, and you can go up and down this nested structure to understand either whole system in terms of the parts, or the parts in terms of how they contribute to the larger system. I don't know if this really speaks to the question, but it's one thing that comes to mind. Thank you, though.
Okay, thank you. I don't think we have further questions. So thank you, Gualtiero.
Thank you.
Carlos?
Okay. Since we are already running out of time, and I think Marco needs to go already, I guess. And so I guess this is a good time for us to finish the meeting. I want to thank you again, everybody who could have been here. I think that I want to thank again Marco and Piccinini for their kindness and their availability. It's been a wonderful conversation. And I hope we can meet again in further events, in future events. So thank you, everybody. I'm going to stop the recording now.
Thank you,
Thank you.
everyone.
Bye.
Thanks, Marco.
Thank you all.
Thank you, Gualtiero.
Thanks, Marco.
Thank you.